Okay, we're good. I'm going to go through your paper, and I'm going to try to stick to under an hour. So hopefully you would have already done this. This would be in your exam pack. Going to go. Yeah. All right. So I guess we'll just go straight into it. So this is what you would have been given. So this is what you would have gotten like 6 weeks ago. All right. These normally start with pretty easy questions, and this one is no exception. So if f of x is that, what's f of minus 3? So I'm just shoving minus 3 into each of those. So x squared minus 5 times x plus 3. So that's 9 plus 15 plus 3. That's 9 plus 18, which is 27. Boom. Keep in mind, the multiple choice should take 15 minutes. That's a good little indicator. Okay, there's a lot of words here, but it's basically just like, here's some information about your data. They calculated Pearson's correlation coefficient. So is there a correlation between anxiety and these 4 factors? And the results are here. So if you're if the correlation coefficient is close to -1, then it's a strong negative correlation, which means as anxiety goes up, homework goes down, or hours spent on homework goes down. So, or the way around. So the more you spend on homework, the less anxiety. Does that make sense? More anxiety, more time spent on social media. More anxiety, less hours of sleep. Yeah, okay, this is making sense. Anyway, which row shows the weakest and strongest? So it doesn't say positive or negative, so you're looking for values that are closest to -1 or 1. So closest to absolute value of 1, if you wanted to think of it like that. So that one is the closest thing to -1, and that one is the furthest thing from -1 or 1. So that's the strong one, and that's the weak one. So hours spent on homework is strong, so that's one of these two. Time on social media is the weak one, so it's one of these two, so that means B must be my answer. Which of the following is equivalent to the derivative of that? So whenever you got something like this, rewrite it like this. The derivative is going to be equal to, so I drop the power, times by the front, that's the same as -1 on x squared, so that's A. Okay, this bloke flips a biased coin. Probability of heads is 3 on 5. Probability of tails is therefore 2 on 5, or 1 minus 3 on 5. The probability tails, so tails twice, is 2 on 5 times 2 on 5, which is 4 on 25, which is A. Arithmetic sequence has first term, 7, and common difference, 6 on 5. What's the closest value of the 29th term, so T29? Is what I don't know. T of n is A outside of n minus 1, oops, A plus n minus 1 D, almost stuffed it up. I know what A is. I know what D is. T of 29 is going to be 7 plus 29 minus 1 times 6 on 5 equals 7 plus 28 times 6 on 5. Calculator time, 7 plus 28 times 6 on 5 is around about 40.6. Hello, 40.6. That was exactly. Was it meant to be rounded? I don't know. Now, this one requires a little bit of thinking, like outside of the box thinking, but continuous random variable, so remember those probability functions that look like thingos, has equal mean, equal median, and equal mode. So you think of a graph, tenets, blah, blah, blah. The average needs to be the same. So the average needs to be the same as the middle. So the average needs to occur at the middle. So you think of, like, I don't know, maybe that's the average in the middle. And it also needs to be the mode. So it needs to be the highest point. Whoa. So in other words, the graph kind of needs to look like, I don't know, like this or something. there's the mode, so the top. The average would suggest it's kind of in the middle, and so this point, there's an even amount of points on this side and this side, but that point also needs to be the middle. So in other words, we're looking for something that's symmetric. So all this stuff tells us is that it's symmetric. Whoops. Rick, why is that going all blurry? Anyway, so which of these graphs are not symmetric? Now, this one is just a straight line, so happy. This one, if you were to expand that, is a parabola, symmetric. This one is, if you remember, r squared minus x squared, that's a semicircle, symmetric. This one's an exponential, which the x is that way, which means it looks like this. Pretty sure that's not symmetric, so not this one. Okay. Look, there's a couple of things you can do with this one. You could go to Google and type in what is sec x. Hopefully, this doesn't type in something without a C in it. You could look at the graph of sec x, or if you just so happen to be able to memorize what the graph of sec x look like, then nice. But I wouldn't expect anyone to be able to do that because I certainly don't really know what the graph looks like. Now, it is the same as one on cos x. So there's something I guess we could do here. All right, so the domain is what breaks this thing. Well, what breaks this thing is that can't be 0. So cos x can't be 0, because otherwise you'd have the bottom of a fraction that equals 0 and then it would break. So that's generally the things you look for in a domain. So that can't equal 0. So you think about the values where x is 0 in cos. So where's my sheet? So you can think about when cos is 0, and that's at 90 degrees. We've got this in radians, so that's at pi on 2. It's also at 3 pi on 2. And you can just think of it like the unit circle. I'll just draw a quick unit circle. Sine cos is the x value. So here the x value is 0. Here the x value is also 0. So that's 90 degrees. That's 270 degrees. And you just keep going around the circle. So really, I could just keep going and add pi on 2 to each of these. So like 5 pi on 2 is the next one, and so on. So the domain isn't everything. It's everything except for these values. So it's one of these two. Now, you just got to think about, is it multiples of pi, or is it multiples of pi added on to pi on 2? So if you think about this value here, how do I get from here to here? Well, I have to add 2 pi on 2, which is pi. So I'm starting at pi on 2, and then I add pi. And then to get from here to here, I also add pi. So in order to get all of my values for which cos doesn't exist, I need to find pi on 2, and then add multiples of pi. That's what's happening here. So like to get from here to here, I add 2 pi. To get from here to here to the next one, I have to add 3 pi. I hope that makes some kind of sense. So in other words, it's C because of this. This is a little bit harder to prove, but once you've gotten this, I think you're fine. It is multiple choice. You shouldn't be spending too long on it. Yeah. And it's also kind of a clue that there's 3 solutions that have this and only one that has this. It's kind of, I guess, a trick you could look for. Yeah. Anyway, let's keep going. Have I broken 15 minutes? No. Okay. Which graph represents this exponential? You might be like, oh, okay, obviously not this and this, but just be really careful because there's an exponential and a log in here. So this can be simplified as if I get this, I can't just go like this, right? I need this 2 to go. So if I go like this, and then the squared comes up here, it's actually on top of this. Maybe I should go like that. And then I can cancel the exponential and the log, and then I'm just left with x plus 1 squared. You'll notice that that's just x squared, which is a parabola, and it's been moved to the left 1. A parabola moved to the left 1. I'm pretty sure that's this. So that's that. Another one that involves a little bit of thought. I hope my mic's okay. I can't I've gotten this far without it. Which of the following is going to give the area? So you just got to be careful because some of these are going to give you negative areas and stuff like that. So if you think about, okay, x minus 2 between 0 and 2. So just what I'd quickly do in this case is just label each line. Like this is obviously 2 lines. It says the absolute value, but none of these have an absolute value except this one. Let me prove to you why it's not this one. It's because x minus 2 is this line here. So it's got a positive gradient and it's down 2. So it's this line here. If you found the integral underneath 0 to 4 of this line, so from here to here, that's symmetric. So this is actually going to give you 0, or the absolute value of 0, which is still just 0. So that's not going to give you a correct area. So it's not this one. If you then think about, for the same reason, it's not this one, essentially. So it's one of the first two. If you look at this one, that's going to give you, so x minus 2 between 0 and 2 is going to be this one, and then that tells you they're going to times the area by 2. So it's going to give you 2 times this area down there. But again, because it's underneath the x-axis, it's going to give you a negative. So it's not this one. So just by process of elimination, it's this. But when you think about it, it's from 0 to 2, x minus 2. So x minus 2 is this. From 0 to 2, that's still this area. It's 2 times that, and then they put a negative there. Because this is going to give me a negative value, they then put another negative out there. It's going to cancel, and it's actually going to give me a positive area. So it's B. Last question, and I hate these questions, and I'm sorry that I put this on your exam, but I was curious as to what reasoning and deduction people could come up with, because the problem with questions like this is it doesn't give you enough information on these things, which is why I kind of hate them. Yeah, anyway. So what's true about H3? So if you just think about, if I just start by examining when x equals 3, you'll notice that g of x is pretty close to 0. So where am I looking? So g of x, so this is g of x is, well, sorry, g of 3 is pretty close to 0. That would be, I guess, my first observation. And f of 3 is pretty close to, so just going at 3, I don't know, 1.5, call it, ish. So that means h of x, which is equal to g of f of x. That means h of 3 is equal to g of f of 3, okay, which is g of, now f of 3 we said was around about 1.5, so around about 1.5. So now think about what is g of 1.5. So g of 1.5, that's there, that's around about 1. Okay, so how does that help me? Well, to be honest, really it kind of doesn't. But then you think about what's happening kind of like either side of it. So I then go, all right, well, what's happening at, I don't know, g of, because it's not these two, because I can't think of an explanation as to why it's not those two. It doesn't really make sense to consider the local maximum, the local minimum, given these two graphs. It's kind of easier to determine whether they're increasing or decreasing. There's no stationary point. Like I've just identified that h of 3 is around about 1, and at this 1 value, there's no significance to either of the graphs. Like they're not, like the maximum's here and the maximum's there for each of them. There's no minimum. So it kind of doesn't make sense to talk about the maximums and minimums. Anyway, I'm doing g of 2. Now that's around about, 0.5. F of 2 is around about, well, that is the maximum, 2. So then if I had h of 2, that would be g of f of 2, which is g of 2 which is now g of 2 is, so it's a little bit less. G of 3. G of 1, yeah, so g of 2. It was 1.5 before, wasn't it? So it's a little bit less. So what are we calling that? 1.5, maybe? Okay, so then I'd go, all right, well, what about a little bit further? So g of 4. Like, these questions are so dumb. What's g of 4? Well, that's 0. F of 4 is also 0. H of 4 is therefore g of f of 4, which is 0. And g of 0 is, g of 0 is this. So it doesn't really give us much information. Oh yeah, actually it does. That's about 1.5. So now if we just have a look at what we've done, h of 2 is 1.5, h of 3 is 1, and then h of 4 is 1.5. Whoops. So where does that leave you? Well, the answer is it's increasing. So that doesn't help because that looks, this information almost tells you that it's a minimum, doesn't it? So you have to look at it a little bit closer. So I'd have to then go, all right, well, what's 2.5 and then what's 3.5? And at this point, I'd probably just take a guess because, yeah, the answer says it's decreasing, but just based on the information I've just given myself, I'd almost consider that to be a local minimum, even though I said we should rule that out. Damn it, I went over the 15 minutes. Anyway, I don't like these questions because, to be honest, I don't really understand them. But it's only 1 mark. Alright, rationalize the denominator. That's easy. I'm going to times the top and the bottom by root 5. You don't have to do 6 root 5, just root 5. So 5 root 3 on 6 root 5 times by root 5 on root 5. That's equal to 5 root 3 root 5 on 6 times root 5 squared, which is 5 root 15 on 6 times 5, which is 30. And I can simplify that to root 15 on 6. Okay. Gradient of the tangent. So I'm going to differentiate that. So dy dx, not y dash, is going to be derivative over original. I can simplify that as 1 on x. And then the derivative, actually, maybe I should write it like this. The derivative at 4 is going to be 1 on 4. That's literally it. Okay. Annuity question. Love it. The way they word these are so dumb, but it's essentially just, here's an annuity table. This is how much I'm putting in for 3 years at this rate, but it's compounded quarterly. So my period is not going to be 3 years. It's going to be 3 times 4, which is 12 quarters. And then my rate is going to be, instead of 3% per annum, I'm going to divide it by 4. So then that's 0.75% per quarter. Per quarter? PQ? Is that a thing? Anyway. Okay, so then I looked that up on the table. So 12 and 0.75, 12, 0.75, so that's this. So then what lump sum? So could be invested. So investment 1.4349. So that's how much I would make for $1. But I want to know what $2,500 is. And that's equal to $2,858.7.24. So that's the, call that the present value. I don't know why I wrote for then. Present value. Okay. Because it's a present value table. Anyway, all right. Find all the values of theta that satisfy that. So 2 sine theta equals -1, sine theta equals -1/2. So then I draw my quick circle. When does sine equal half? Well, that's at 30 degrees. This is in radians, so pi on 6 degrees. Radians, sorry. Now, it's all stations to central. I want to know when it's negative. So that's going to be not these two. It'll be these two. So when that's pi on 6 and that's pi on 6. So that means this one is pi plus pi on 6. And this one here is 360 minus pi on 6. So 360 is 2 pi minus pi on 6. I could probably leave it like that, but let's just, that's 6 pi on 6 plus pi on 6, and that's 12 pi on 6 minus pi on 6. That's 7 pi on 6 and 11 pi on 6. And if you're not sure, if you're not sure, you can substitute each of those into there, and they should make sense. Okay. Events A and B are non-mutually exclusive. That means if I were to draw a Venn diagram, they would overlap. So let's do that. Boom, boom. Now this is A, that's B. Probability of A is 0.35. Probability of B is 0.55, and the, okay, so all of them together, not that. Okay, so the probability of not any of them occurring is 0.2. So this 0.2 is out here. Use a Venn diagram to represent the following probabilities. Okay, this is a bit of a trick question because it hasn't told you what the intersection is. So it's really easy to just go, okay, that goes here and that goes here. But you just got to be careful because it's, you kind of got to do it backwards. You've got to think about the overlap first. So the probability of the overlap, which is A intersection B, is going to be all of it added up, minus 1, or 1 minus that. So 1 minus 0.35, nope, plus 0.55, plus 0.2. So that's 0.9, that's 1.1. Actually, it's the other way around, sorry. Otherwise, I would have gotten a negative answer. That's 0.1, so the intersection goes there. And then that's what's counted twice. So then we take 0.1 from each of these. So this is 0.25, and this is 0.45. And then I add those up to make sure that that equals 1. And it does. Cool. So all I did was just add that, and that, made sure it equaled 1, which it does. Okay. Determine probability of B given A. So I'm pretty sure this is on your reference sheet, but probability of B given A is equal to the probability of their intersection, I'm pretty sure. Yep. A union B over the probability of the second one. Alright, so this is probability of B given A. Okay, we found the intersection, that was 0.1. And then probability of A was 0.2, oh no, 0.35. Okay, if I simplify that out, that's the same as 2 on 7. So my things, okay. Now, if the probability of B given A does not equal the probability of B, then they are not independent. And we can see that, so therefore, since probability of B given A is 2 on 7, and that does not equal 0.45, at least I'm pretty sure it doesn't. 2 on 7 is 0.28, therefore not independent. We haven't done that in ages. We did that in year 11. Oh, the funnest questions ever. Here's f of x, sketch f dash x. Alright, so always do them on top of each other. It's already given you an axis, so that's good. Now, showing the correct x-intercepts. Alright, so between, I like to kind of break it up. We've got this part here, this part around there, then you've got that, which is that, and you've got this, so break up like the stationary points. Okay, now in the first part, it has a negative gradient and then goes towards 0. So it's a it's negative towards 0, starting off like that. Then it turns and it's got a positive gradient, positive. Let's draw the lines. Minus, 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 minus. Then it's positive, 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 and then it gets to 0 again. So there's also a point of inflection here. So it's let me zoom in. It's kind of positive, really positive, and then kind of positive again. So, where's Charlotte? So kind of positive, really positive, and then kind of positive. Just be my artist lines here. And then here it's negative, negative, really negative, negative, negative. So negative, negative, really negative, negative, negative. So you can see these points here are my points of inflection. So you can see this concavity and then this concavity. That's this point here. And then here I've got very positive and it just skyrockets. So very positive and it just skyrockets. Also notice that this thing has 3 turns. Then I differentiate and now it's only got 2 turns. And guess what? Now I have to do it again. So the second derivative. Okay, so this one I guess we break up a little bit differently. Break it up like that and like that. So that's between 2 and 1. So that's there, and then on 1, just there. Okay, now same thing. Let's draw our little things. Let's drawing in light red. It's got positive gradients, positive gradients, positive gradients towards 0. So positive gradient towards 0, positive towards 0. And then it's negative, negative, really negative, negative, negative. So negative, negative, very negative, and then starts going back towards 0, which is here. And then it's very positive. Very positive. So basically a parabola. Just draw a parabola, can't we? Alright. Maybe I'll put my plus signs. So there we go. And again, this turns twice, this thing only turns once, so we're good. It wants approximate x-intercepts. My lines kind of suggest where my intercepts are. Okay, so that was 4 marks. I believe these are our last questions. 29 minutes. We're going strong. A company, I actually like this. A company is just trying to distinguish between humans and bots in an online video game. Their company gathers data on 100 players. The average amount of clicks for these players is displayed below. So clicks per minute. Let's just fill in this cumulative frequency table. 4 plus 12 is 16, plus 22 is 18, 38. Okay, well now I can't do this one. I need my calculator. 75, 95. I'm sure people know how to fill in a cumulative frequency table. This plus this gives this. This plus this gives this. This plus this gives this. Anyway, now I need to complete my frequency histogram and draw the ogive, or the polygon. Ogive is such a stupid word. Okay, so 0 to 19 clicks, the frequency was 4, so 1, 2, 3, 4, that's pretty blurry. 1, 2, 3, so that. I'll call that in later. What was it on? 16. We're drawing a cumulative one, aren't we? Okay, so 16. 20, 19, 18, 17, 16. And then 38. Jesus, 38 is that. 75. Oh my god. 80, 79, 78, 76. No, 77, 76, 75. So that's there. And then from 80 to 95. 1, so 100, 99, 98, 97, 96, 95. No. And then 100, 100. Stop. Okay. Oh, for God's sakes. Should go like that. Right. And then my polygon goes from. I'm not sure I'm that right. No. So it goes to the little corners. Please stop drawing. Let's just color that in. I hate that. Alright. There's my cumulative frequency histogram. So 1 mark and the polygon, 2nd mark. Okay. Now it wants to find the interquartile range. So that means I need to find my median and the median of medians. So my median is going to be where 50 is. So I look for 50. That's, god damn it. Let's just eyeball halfway. And call that the median. Now 75 is going to give me Q3. We found 75 before. That was just this. And then 25 is going to give me 1, 2, 3, 4. Yeah. Okay. So that's about there. I hate that that's crooked. And this one. Okay, so we got this. Alright. So this here is Q1. That's Q3. And our median is in there somewhere. So Q1 was, what are we calling that? Just shy of 50. Oh, I don't know. Do we want to keep it as, yeah, let's just call that 48, shall we? 48. Q3 is exactly 80. That's nice. So that means the interquartile range is 80 minus 48, which is 32. Happy with that? Obviously your answers are going to be a little bit different depending on where your graph is, but get what you get. Now, it's this last question that's a little bit up to interpretation. I probably wouldn't dock your marks for the last part, but they're considering flagging accounts whose number of clicks per minute qualifies as an outlier, so like beyond average. What are the ranges of the numbers of clicks that would qualify as an outlier? So this is on your reference sheet. So the outlier lower is Q1 minus 1.5 times interquartile range. So that's 48 minus 1.5 times 32, which is, off the top of my head, 10. And the higher outlier is Q3 plus 1.5 IQR, which is 80 plus 1.5 times 32, and that's 128. Now, this is the part where it's kind of up to you, but there's a little bit of interpretation. It says, what are the range of the numbers of clicks that would classify as an outlier? So we've got anything, I should conclude, so anything less than 10 or greater than 128. Now, comment on the suitability of this criteria. Think about number of clicks. Like, some random user might not click 10 times in a minute. But can you think of a user that's going to click 128 times in a minute? And whether or not it's suitable for you to be like, oh, I'm going to kick you off my website because you didn't click 10 times. Or I'm going to kick you off my website because you clicked 2 times every second, more than 2 times every second, which is pretty unrealistic unless your website is a game that involves clicking as fast as you can. So I guess what you would put here, I haven't really left enough lines, have I? But what you would probably put here is something like, it is suitable for the less than 10 case because it may not be the case that the person would have clicked 10 times, like that's perfectly valid. Is it perfectly valid that 128 clicks occurred in a minute on average, suggesting that more was done and less than was done? So is that realistic? And they're the sorts of things I guess you can comment on, but I'd leave that up to you. Like, comment on the suitability. I'd give you a mark for that, probably, as long as your answer made some kind of logic. That's it. That's the first part. So that only took 38 minutes, which is nice. We didn't really do question 10 properly, but other than that, I think that was pretty successful.